It always helps to look at the graph of a system of equations before you start to solve it. This one's rather difficult to graph, but with technology I was able to. Notice there's 2 points of intersection of these curves, so we expect there to be 2 solutions. Both by symmetry they have the same y-coordinate and opposite x-coordinates, it appears. So anyway, let's solve this. To solve these equations, the elimination method actually seems to work. So, if you multiply the second equation times -1, and leave the top one just as it is, we get x squared y equals 4 minus y, and this one becomes negative x squared y equals negative 2y plus 1. Now we can add these equations together. The x squared y term goes away, and we've got negative y, negative 2y is negative 3y, and 4 plus 1 is 5. Add 3y to both sides of this, and we get that 3y is equal to 5. And dividing by 3 on both sides, we get that y equals 5/3. So we've solved for y, and now we can go back and try to solve for x using any of the previous equations. So, well, there's either one is equally good. So let's use the second one. So substituting that value of y into the second equation, we get that x squared times y, which is 5/3, is equal to 2 times 5/3 minus 1. This means that 5x squared divided by 3 is equal to 10 divided by 3 minus 3 divided by 3. And 10/3 minus 3/3 is 7/3. So multiplying both sides of this times 3, the 3's cancel, so we're left with 5x squared is equal to 7. Dividing by 5, we get that x squared is equal to 7/5. So x is equal to plus or minus the square root of 7/5. We need to rationalize the denominator here. So we end up getting that x is equal to plus or minus the square root of 7 times 5 is 35 over 5 times 5 is 5. So we have 2 values for x and 1 value for y. That's what we expected from looking at the graph. And so the solution point, the intersection of these 2 curves, is given by the 2 points with x equal negative radical 35 divided by 5, comma 5/3. And the other point is radical 35 divided by 5, comma 5/3. So these are the 2 points of intersection of these curves and the 2 solution points to this nonlinear system of equations.